5,000 years ago, a culture of horse-riding herders from the grasslands north of the Black Sea began moving west. Within a few centuries, they had replaced up to 75% of the gene pool of Central and Western Europe, not through a single invasion, not through a single battle, through a migration so massive and so sustained that it rewrote the genetic map of an entire continent. The steppe, flat, treeless, wind-scoured, an ocean of grass stretching from the Danube to the Urals, the incubator of the most consequential migration in European history. The Yamna, a name most people have never heard, and the single largest demographic event in European history. In 2015, two landmark ancient DNA studies, published simultaneously in Nature, proved what archaeologists had argued about for decades. Wolfgang Hack's team at the Max Planck Institute and Morten Allentoft's team at the University of Copenhagen both arrived at the same conclusion from different datasets. They sequenced hundreds of ancient genomes, spanning 5,000 years of European prehistory, and the data showed a continental-scale population replacement centered around 3,000 years before the Common Era. The bones inside the burial mounds had been waiting 5,000 years. When the sequencers read their DNA, the data rewrote a continent's origin story. Before the Yamna migration, Europe was populated by Neolithic farmers, descendants of the Anatolian agriculturalists who had brought farming from the Near East starting around 7,000 years ago. After the migration, those farming populations were largely replaced. In some regions, Britain, Iberia, Scandinavia, the genetic turnover exceeded 90%. Britain, 90%, Central Europe, 75%. The numbers didn't describe gradual change, they described an event. So who were the Yamnaya? And how did a culture from the grasslands of southern Russia and Ukraine transform the genetics of a continent? The Yamnaya culture emerged around 3300 before the Common Era on the Pontic-Caspian steppe, the vast grassland stretching from modern Ukraine to Kazakhstan, between the Black Sea and the Caspian Sea. They were pastoral nomads. They herded cattle, sheep, and goats across enormous territories. They were among the first people to domesticate the horse and ride it, and they were the first culture to use wheeled wagons extensively. The wagons changed everything. Before wheels, pastoral nomads were limited to territories. Their herds could walk in a season. With wagons, they could carry supplies, shelter, and families across continental distances. The horse changed everything twice. First as a herded animal for milk and meat, then as a ridden animal for speed and range. The Yamnaya mastered both, and they buried their dead in a distinctive way, in deep pits covered by earthen mounds called kurgans, the body laid on its back with knees raised, covered in red ochre. Thousands of kurgans dot the steppe from Ukraine to the Urals. Each one is a time capsule, and when geneticists opened them, the DNA inside told a story of expansion on a scale no one had imagined. The genetic profile of the Yamnaya was itself a mixture. They carried two major ancestry components that had never been combined before: Eastern hunter-gatherer ancestry from the indigenous foraging populations of the steppe and forest steppe zone, and Caucasus hunter-gatherer ancestry from populations south of the Caucasus Mountains, near modern Georgia and Armenia. These two populations had been separated for thousands of years when they merged on the steppe. Sometime before 3500 BCE, they created a genetically distinct population that had no precedent in European prehistory. Nothing like this combination had existed before, and nothing in Europe could resist what it was about to produce. The Yamnaya carried something else that would reshape Europe: their language. The leading theory in historical linguistics, the steppe hypothesis, argues that the Yamnaya, or their immediate ancestors, spoke Proto-Indo-European, the ancestral language of nearly all European languages and many Asian ones: English, Spanish, Russian, Hindi, Greek, Persian, German. Nearly half the world's population speaks an Indo-European language today, and the DNA evidence now suggests those languages spread with the Yamnaya migration. The languages spoken by 3 billion people today may trace back to campfires on the Pontic steppe 5,000 years ago. Language doesn't fossilize. It leaves no DNA. But the correlation between Yamnaya ancestry and Indo-European languages is now so strong that most geneticists and a growing number of linguists consider the steppe hypothesis confirmed by ancient DNA. Whatever language they spoke, it carried the words that would evolve into every tongue from Icelandic to Bengali, the vocabulary of agriculture, kinship, and the wheel, all reconstructed in Proto-European. The migration itself happened in waves. The first major westward movement appears in the archaeological record as the corded ware culture. named after their distinctive cord-decorated pottery, appearing across Central and Northern Europe around 2900 BCE. The genetic data is unambiguous. Corded ware individuals carry massive Yamna ancestry, 50 to 75% in most samples. They appeared in Central Europe within a few generations and rapidly became the dominant population. The Neolithic farming populations that had inhabited Europe for 3,000 years were genetically swamped within centuries, not slowly diluted over millennia, replaced within a handful of generations. 2 centuries, that is all it took. The farming communities that had built Europe's first monuments were genetically overwritten. The second wave hit Britain, and it was even more dramatic. Around 2500 BCE, people carrying beaker pottery and heavy Yamna ancestry crossed the English Channel. Within 300 years, they had replaced approximately 90% of the existing British gene pool. The people who built Stonehenge's earliest phases were Neolithic farmers. The people who built its final phase, the famous stone circle, were genetically almost entirely Yamna descended. Stonehenge's builders changed mid-construction. The monument spans the replacement. The people who erected the Great Sarsen stones spoke a different language and carried different DNA than the people who had first consecrated the site. This raises the question nobody can avoid. How does 75 to 90% of a continent's gene pool get replaced? What happened to the Neolithic farmers? The honest answer is we don't fully know, but the evidence points to multiple factors operating simultaneously. First, plague in 2015. The same year the migration studies were published, ancient DNA revealed that early strains of Yersinia pestis, the plague bacterium, were circulating in Yamna era populations. The plague bacterium left its signature in their teeth. Yersinia pestis DNA, 5,000 years old, preserved in the dental pulp of steppe burials. The steppe herders may have carried plague with them, or ahead of them. If Neolithic farming communities had no immunity to steppe origin diseases, the population collapse could have been catastrophic before the migrants even arrived. The Americas offer a parallel. When Europeans arrived in the 15th century, diseases preceded them. Smallpox and measles devastated indigenous populations before most ever saw a European face. The Yamna migration may have followed the same pattern. Diseased land is empty land. Empty land is easy land. The pattern is as old as human migration itself. Second, violence. And here the evidence is uncomfortable. Mass graves from the late Neolithic period in Central Europe show evidence of extreme violence. Entire communities killed, including women and children. The timing coincides with the arrival of steppe ancestry. At Uhlau in Germany, a mass grave from roughly 2800 BCE contained a family, parents and children, identified by DNA. They were killed by blunt force trauma. Their genetic profile was Neolithic farmer. The Y chromosome data tells the starkest story. In many regions, the Neolithic paternal lineages, the Y chromosome haplogroups carried by farming men, virtually disappear after the Yamna arrival. The violence wasn't random. It was systematic. Entire communities destroyed at once. And the DNA of the victims tells us who they were, Neolithic farmers, caught in the path of change. The maternal lineages, mitochondrial DNA, show more continuity. Neolithic women's lineages survived at higher rates than Neolithic men's lineages. The pattern suggests that Yamna men replaced Neolithic men while incorporating Neolithic women into the new population. Whether through conquest, social dominance, or some combination, the result was the same, male-mediated replacement. But here is the twist. The violence theory alone can't explain the scale, and the evidence also points to a third factor, demographic advantage. The Yamna had horses, wagons, metal weapons, and a pastoral economy that could exploit territory that farming couldn't reach. They could move faster, occupy more land, and sustain larger populations in marginal environments. Neolithic farming communities were tied to their fields. The steppe herders were mobile, in a landscape being reshaped by climate fluctuations around 3000 BCE. Mobility was the decisive advantage. A mounted warrior could cover 50 kilometers in a day. A Neolithic farming community couldn't move at all. The speed asymmetry was decisive. Climate cooling and drying in the late 4th millennium BCE stressed Neolithic farming economies across Europe. Crop yields fell, populations contracted, and into that vacuum came the steppe herders. The herders could survive where the farmers couldn't, and when the farmland failed, the herders were already there. The Yamna didn't just bring genes and language, they brought a social structure, that fundamentally altered how European societies were organized. Neolithic European societies appear to have been relatively egalitarian. Evidence from burial sites shows limited differentiation in grave goods. The Yamna brought hierarchical social structures with marked status differences. Yamna-derived burials in Europe show extreme inequality. Some individuals were buried with bronze weapons, gold ornaments, and sacrificed horses. Others had almost nothing. Social hierarchy arrived with the steppe DNA, and the kinship patterns were patrilineal. DNA from corded ware cemeteries shows that communities were organized around male lineages, fathers, sons, and brothers buried together, with wives coming from outside groups. Sons stayed. Daughters moved. The genetic signature of this system is unmistakable in the burial DNA. Women moved between communities at marriage. Men stayed. The patrilineal system concentrated male genetic lineages and spread female lineages. Exactly the pattern the ancient DNA confirms. The lactose tolerance connection adds another layer. The Yamna carried the genetic variant for adult lactase persistence, the ability to digest milk as an adult at moderate frequencies. Milk, the survival advantage that sounds mundane but transformed a continent. Those who could digest it had more calories. More calories meant more children, and the gene spread. In Neolithic Europe, almost nobody could digest milk past childhood. The Yamna brought the gene variant, and over the next 3,000 years, natural selection drove it to near fixation in Northern Europe. The ability to digest milk was a survival advantage for pastoralists. More calories from herds meant more children. More children meant the gene spread faster. The Yamna didn't just replace European genes, they replaced the European diet. But the replacement wasn't uniform, and the exceptions are as revealing as the pattern. Sardinia preserves the highest proportion of pre-Yamna Neolithic farmer ancestry in Europe. The island's genetic isolation protected it from the continental scale replacement. Modern Sardinians are the closest living genetic relatives of Europe's Neolithic farmers, the people who dominated the continent before the steppe herders arrived. Their DNA is a window into pre-Yamna Europe. The Basque Country in northern Spain shows a similar pattern: elevated Neolithic farmer ancestry and a non-Indo-European language that may predate the Yamna expansion. The Basque speak a language that has no known relatives. It may be the oldest living language in Europe. A survivor from before the steppe migration rewrote the linguistic map. If the Basque language survived the Yamna replacement, it may be the last living echo of what Neolithic Europe sounded like before the steppe herders arrived. The edges of Europe, islands, mountains, peninsulas, preserved what the plains could not, genetic remnants of the world before the steppe arrived. The implications of the Yamna studies reach beyond prehistory. They reshape how we think about European identity itself. Modern Europeans are a three-part mixture: Western hunter-gatherer ancestry from the post-Ice Age foragers, Neolithic farmer ancestry from the Anatolian agriculturalists, and steppe ancestry from the Yamna. Every European alive today carries all three components. The proportions vary by region: more steppe ancestry in the north, more farmer ancestry in the south. But the basic mixture is universal. The idea of a single natives European population is genetically meaningless. Every European is the product of at least three major migrations, and that is before the Iron Age, the Roman period, the Viking Age, and every subsequent wave. There is no original European. There are only layers. The Yamna studies also opened a debate that geneticists and archaeologists are still having. Does DNA replacement mean cultural replacement, or can cultures survive their own genomes? In some regions, Neolithic cultural practices, megalithic monument building, specific pottery styles, burial rites, continued for centuries after the genetic turnover. The new populations adopted local traditions, even as they replaced local genes. In other regions, the cultural break was total. New pottery, new burial rites, new settlement patterns, new everything, genes and culture replaced together. The pottery changed, the metalwork changed, the burial rites changed. In some places, everything changed at once. In others, the old and new existed side by side for generations. The relationship between genes and culture is never simple, and the Yamna migration proves it. Different regions experience the same demographic event in radically different cultural ways. Every new genome adds a pixel to the picture, and the picture keeps getting more complicated, which means it keeps getting more true. New ancient genomes are being published every month. Each one adds resolution to the picture, and the Yamna story gets more complex, not less. with every sample. What was once described as a simple invasion is now understood as a centuries-long process involving plague, climate change, technological advantage, social organization, and sustained demographic pressure. No single cause, no single event. A cascade of pressures that transformed Europe more thoroughly than any empire that followed. If you want to see how DNA is rewriting more of what we thought we knew about the ancient world, subscribe. The steppe keeps giving up its secrets, and every kurgan is a genome waiting to speak. 5,000 years ago, the steppe moved west. Languages changed, genes changed, societies changed, and every European alive today carries the proof in a genome that was assembled from 3 worlds that collided on the plains of prehistoric Europe. Somewhere beneath those burial mounds, more genomes are waiting, and the story they tell isn't about conquest or collapse. It is about the fact that every population alive today is a mixture, and always was.